So what we've done so far in class has basically been exploring the building blocks, the representations of data that are part of a computer program. And now we're going to actually start getting into the more unique aspects of computing, where instead of essentially what we've done so far is just kind of like we've used Python as a calculator, either for simple manipulation of strings or simple manipulation of numbers. And now we're going to get into more of what really makes computers powerful, and that is through the variety of compound statements that are in a programming language. So let's go over these. So all but the simplest programs need to have code structures that are blocks of code that are either conditionally executed, used repeatedly, or executed together. So what do I mean by conditionally executed? So that would be where your computer would do one thing under one circumstances and another in a different circumstance. So you can think of, if the patient is a woman, then do a pregnancy test is an example of a conditional execution. Or if a patient has fever and has indications of pneumonia on x-ray, then prescribe antibiotics. So you're doing one thing if it's a woman, another thing if it's a man. One thing if a person has a fever, another if they don't. So those are examples of conditionally executed blocks. Blocks of code that are used repeatedly, this would be something like, imagine you're making butter. So while the cream is not butter, keep churning, or ice cream. While the patient is not breathing, keep performing CPR. So you're repeatedly doing the same thing until some condition is met. Thinking of blocks of code or programming statements that are executed together, there's a famous example that's used in computer science education about making a peanut butter and jam sandwich. And it's usually used to illustrate the level of detail and literalness that a computer requires. But if we're thinking about all the steps that go together, if this is what it means to make a sandwich, then there's a variety of statements or executions that need to be done together, like open the bread bag, take out a slice of bread, put the slice of bread on a plate, close the bread bag, open the peanut butter, spread peanut butter on the slice of bread, and so on. So these are all statements or actions that go together in the concept of making a sandwich. In a medical domain, you might think of, okay, when we check in a patient, there's things that we're always going to do together. We're going to get the patient name. We're going to get the patient date of birth. We're going to get insurance information. We're going to get the chief complaint, and so on. Okay, so how does Python define compound statements? Oh, the typos. Let's see. Fix that. So how does Python defines compound statements? So Python uses colons to mark the beginning of a compound statement. The colons are used in conjunction with indentation levels. So compound statements end when the indentation level returns to the value prior to the colon, and I will illustrate this in a second. You can also have compound statements inside of compound statements. So here's an example. While I'm on the airplane, and if I was writing this in kind of Python code, I'd have a colon there. So then I'm going to say, well, while I'm on the airplane, while my computer still has battery, if I mark this with a colon, then I'm going to do some work. So I'm going to be doing work until I don't have any battery left on my computer, and then I'm going to come down here, and while the onboard entertainment is available, I'm going to watch a movie. So you see here's, in this case, this is my first level of indentation. So it goes from while to here, but then within this while, I have an indentation to do some work. Of course, if I'm keeping up my same editing here, I would put a colon here, and then I'd have the indentation there. So blocks of code defined with a colon starts it, An indentation level then follows the colon, and when that indentation level returns to the indentation level prior to the colon, we're out of our compound statement. Okay, let me see. Okay. So I just said we use indentation to define blocks. So a block can be thought of as a group of statements that are related to each other. So going back to the examples we had before, statements that are all executed if a condition is true, statements that are repeatedly executed together, statements that constitute a function, statements that constitute a class. And we'll talk about functions in the following module and classes later. So some people think that requiring indentation is bad, and other programming languages don't use indentation to define blocks. For example, C and Java use curly brackets. So an opening curly bracket defines the start of a block, and a closing curly bracket marks the end of a block. And so you can write C or Java without making any use of indentation. You could write it all on one line. So the people that think required indentation is bad, I think they have memories of Fortran. And Fortran, used the first 7 columns on a line had specific meaning. And there was like a continuation line, a comment column, and so forth. And so there were always problems of that you didn't indent past 7 spaces or whatever that were kind of a problem when I was learning how to use Fortran. But I think the people that complain about indentation as a requirement are wrong, because indentation has some very nice benefits. So primarily, it makes the code very readable for the users, for the programmers, for etc. So the indentation allows you to quickly scan the program and recognize the program structure. And even languages that don't require indentation, such as C, are usually written with indentation rules similar to Python, so that the code is readable. So how much do you have to indent? Python doesn't care how much you indent as long as you are consistent. That is, for a particular block that you define, all the indentation has to be consistent. That being said, different blocks can have different indentation. So I may indent one block with 1 space and another block with 4 spaces, and that's perfectly fine from a Python point of view. So what's the trade-off between a lot or a little bit of indentation? So if you indent too little, you don't give much visual advantage for scanning the code and recognizing the structure. If you indent too much, you won't have much space to work with on a line. And so the standard indentation is 4 spaces. So if we look to Python has its own official style guide. Other organizations have their style guide. So I just pulled out the Google Python style guide. And this is the quote of their instructions to their coders. Indent your code block with 4 spaces. Never use tabs or mix tabs with spaces. In cases of implied line continuation, you should align wrapped elements either vertically, as per the example in the line length section, or using a hanging indent of 4 spaces, in which case there should be no argument on the first line. Okay, so 4 spaces. Most Python editors default indentation to 4 spaces, although users can override this value. And this is just another example of why it's important that you use a Python-compatible editor so that the editor will provide the correct indentation for you. So here's some example where I've just indented things one space. So very little indentation, but the code executes perfectly well. Here's the same code where I've done a much larger indentation, and I would just point out that in this block right here, for this if statement, I have 1 level of indentation, and in the following block, I'm using a smaller indentation, but Python doesn't care because the indentation is consistent within the block. So this is, again, an example of nested blocks. So I have a for loop, and within that I have 2 different if statements. So this defines one large block, And then here's a block, here's another block, and then within each of these, there are more indented blocks. Okay. So code blocks defined by a colon followed by an indentation change, increase. Okay, so related to code blocks, we need to discuss what is true and false in Python. So Python provides a Boolean type that represents true and false. And so these are literals in Python, and they're capital T true and capital F false. So objects that evaluate as false in Python are as follows. The Boolean type false, the keyword none, the number 0, and any empty collection such as an empty string, an empty tuple, an empty list, an empty dictionary, or an empty set. Everything else evaluates as true. -1 is true, 1 is true, 0 is false. So you can use the function bool that will convert any expression to a Boolean value, that is if it can be evaluated as true or false. And I frequently run across a message when working with NumPy arrays that the truth or falseness of an array doesn't have meaning. So bool works if the expression can be evaluated as true or false. Okay, so let's just look at some of these. So here I'm going to say what's the value of false, an empty list, a list with 1 in it, a list with 0 in it, and 2 minus 2. And I should have cleared the cells first. So this might be the only one that you might question about because we're saying that 0 is false. But in this case, it's not 0 that we're evaluating. We're evaluating a list with the element 0. So it's the question, is this an empty list? It is not an empty list. It's a list with 0 in it, so that evaluates as true. Okay, so let's explore more this idea of an if statement. I had some in some of the previous code. The if statement is quite simple and almost literal. If the expression is true, then execute the following block as defined by the colon and indents. Okay, a note on style, and I mentioned this in class, in my own inconsistency. Python does not require parentheses around the concept being tested in an if statement. Other languages like C or C++ do, and since those are what I learned first, I tend to write my if statements like that. Python does allow parentheses, although it doesn't require them. And out of habit, I almost always use parentheses, although it's considered bad style, and I'm trying to clean that up, especially for the code that I use in the class. Okay, so here's an example. So I'm defining a string, and I'm going to ask a question. If the name starts with doctor, then I'm going to print a statement. Don't be pretentious. And in this case, I define a new string, no Brian, call the same code. Here I've used parentheses just to demonstrate that it doesn't matter. And when we execute this, we get the message, don't be pretentious, that was executed here. Maybe to make this more differentiable so you can tell that we're not executing this one, we can change this to don't be so pretentious. And that's not what's being executed here. Okay, so where would be some examples you could think of using this? So if kidney function is decreased, then use non-ionic contrast agents. If age is greater than 6 months, then do the vaccination. Okay, sometimes you can just, there's a single if statement that if this statement's true, you do something. But usually what you're going to do, if this is the case, then I'm going to do it, else I'm going to do something else. So usually we think of if, else, if together. So if kidney function is decreased, then use non-ionic contrast, else use ionic contrast. Gotta fix these typos I got in here. Okay, so here's an example. So we're going to import the math library, and we're going to ask the user to enter a real valued number to compute a square root. And we're going to test. We're going to say if the number they enter is less than 0, we're going to print out a message saying that this isn't defined. Else, we're going to print out the square root. So here it's prompting for a number. If I type in a -7, it's going to say real valued square roots are not defined for negative numbers. Well, we can do this again. I can do 9. The square root of 9 is 3. Okay. Now what this isn't going to do, let's see, what if I type in 3 plus 4j? Then I'm getting an error because I have the complex number and I'm using the real math square root. Okay, so even an if-else, that only gives us 2 options. There might be a variety of options that we need. So if you're under 6 months, else if you're under 12, else if you're under 18, else if you're under 65, and so forth. And so Python allows us to build up an arbitrary long list of alternatives to consider by using an else if. So we would have if condition 1, followed by block 1, else if condition 2, followed by block 2, else if condition n, block n, and so forth. So here's an example where we have an if, else if, and else. So if the number is greater than 0, then the number is positive. Else if the number is less than 0, it's negative. Else the number is 0. So 9, number is positive. Number is negative. Number is 0. Okay, comparisons. Comparisons become important in these constructions of these conditions, like the if statements. And we have done some of these in our numeric calculations. But here are a list of the different comparisons in Python. And I'm not claiming that this is exhaustive. So if you want to ask whether x is equal to y, you do a double equal sign. And you got to pay attention to this one because this is a common source of error of just doing a single equal. And that's not a comparison, that's an assignment. So here we can do less than or greater than, less than or equal to or greater than or equal to, not equal to, and then there's some more English sounding ones. So x is y, that's asking is x the same variable as y. X is not y, so you can x is x in y, is x not in y. Okay, so those are comparisons, and then we need ways of creating compound questions, and that is through the use of Boolean operators. And here I have a link to the documentation on this. So and, or, and not. So for this to be true, so take this statement x and y. For this statement to be true, both x and y must be true. X or y means that either x is true or y is true. They can both be true, but they don't need to both be true. So not x is true if x is false. And we should say that and or are short circuits. That means that when you're doing the and, it evaluates the left argument first. If the left argument's false, there's no reason to evaluate the right because you already know that it can't be true, so it does not evaluate the right. So the right argument is only evaluated if the left argument is true. So similarly, so or evaluates right argument only if left argument is false. That is, if it's true, it doesn't matter what the right argument is because it's x or y. But if x is false, then the statement still could be true if the right-hand side is true. Okay, so let's look here at an example. So loose metal equals false, pregnant equals true, sex equals male. And then I'm going to ask, I have this sex is male, not using that here, but if not loose metal and not pregnant, then you're going to say MRI is okay. Otherwise, MRI is contraindicated. So it's contraindicated because of this true. So not loose metal, okay, loose metal is false, so not false is true, and pregnant is true, so not true is false, so true and false is false. So MRI is contraindicated. Okay, so an idea here is how can we rewrite the if statement above to be more concise? Well, let me copy this. And we'll just get rid of the sex equals male because we're not using it. And so what I could say here, let's see, I think what I want to ask is if, say, loose metal or pregnant. If either one of these are true, then not true is going to be false, and it's going to be contraindicated. So if you have loose metal as false and pregnant as false, then the or will be false, and the not will be true. So in this case, we still get MRI as contraindicated. So that is a simpler way of writing the statement we had up here.